Okay, today we are going to disassemble an old computer hard drive. It's a Seagate type brand drive, but many of the drives are very similar regardless. We want to make sure that we have the right tools, and that includes a particular kind of bit. Let's say, I don't know if you can see this, but it's a Torx head. I'm not sure the number. It's a small one, but you want to make sure that you don't try to fight using the wrong tool. Get the right tool, and you can tear these apart. I've done a few of these, so I'm pretty familiar with it. Now, this is the top of the hard drive, and this is the circuit board, or the circuit side, or the bottom side of the hard drive. You can see the different screws. I'm trying to make sure that I'm centered properly here. You can see the different screws. All of them have to come out. They all hold in the circuit board, including this one, which also holds in the motor. This is the motor. And on the top face, there's a sticker, and there's a hidden, one or two hidden screws. I don't know if you can quite see that as a reflection. I'm going to try to get that reflection right. See, I think you can see that reflection of the little divot that I pushed down onto the sticker, and you can see it. Well, what we do is take a small screwdriver and just dig around it and expose the screw, and that's all there is to it. In this particular model, there's another one. I find it by feeling it, dig around the outside, and then out comes the sticker again. Okay, so we'll take off the top. A long time ago, I got tired of using a hand screwdriver. I went to motorized screwdrivers. You'll also notice that I'm doing all this work on my on my workbench, which has a towel on it. The reason for the towel is so when you dump out the little screws, they don't go flying off everywhere. The towel tends to hold on to them. Now I've unscrewed the top. I'm going to go flip it over, unscrew the bottom. Circuit board. Now, one of the reasons I do this is it's kind of a mind-numbing Zen kind of thing where you can let your mind rest and do something good for the planet. For example, you can't just throw away these hard drives. I have a few of them. You can't just throw away the hard drives into the landfill. It's really bad for them. Specifically this part, which the circuit boards have chemicals and heavy metals. Some are recoverable heavy metals to the right people, platinum and gold. Very small amounts, but when you have a lot of circuit boards, you can actually make use of it. So I make sure that I dispose of these properly. I'm going to send it to a recycle place for e-waste. There's just a little pad here, an insulating pad, and I throw that away. Screws, see how they don't fall over? Then the top, usually it just, sometimes it sticks on there a little bit, and you open it up, and there's the inside of the hard drive. Now, inside the lid, there's a little air filter that gets tossed, and the lid can now be recycled. Now, here in the hard drive, you have the recording platters. This is the hub on top of the motor. This is the recording heads and the arm. This is how it moves back and forth. And to precisely position that armature, there are two extremely powerful magnets. This is the top magnet. There's another one below. I'll take this one out. Understand, they're very strong, so be careful not to pinch your fingers. And there's the magnet. The magnet is here, and the backing is simply for mounting it. And this pretty smooth metal surface is not the magnet. This is actually a plating on top of the magnet, because the magnet, the actual rare earth magnet material, is very brittle, and so this holds it in. We'll get to that later in another video. Now, one of the first things we have to do is we have to remove the armature. And the armature goes this far, but it doesn't actually clear the platters until we push down on this little detent here, and then it goes all the way out. Once it clears, we can unscrew it. In this particular model, it's just a flat blade screwdriver. Okay, and the read-write heads pull out, and the ribbon connection, the ribbon signal cable simply tears out. I have tried to take this apart. It's pretty cool looking. I like mechanical things and high precision machining. I just think it's cool. There's probably a couple of very high performance bearings inside. I've tried to get this out. I haven't had any luck tearing that apart, so I just throw this away. Now it's time to remove the platters. Not very many people have a use for these platters. They're certainly no good anymore for the hard drive because they're now dusty. They must be in an absolutely clean, dust-free environment for the read-write heads not to scratch the spinning platters. Okay, I'm going to dump these out. And out comes the first platter. And then there's a little arm here. I push that back, and out come the rest of them. So this particular drive has 3 platters. Sometimes you'll see 1 or 2 or 3 or 4. These are kind of handy for art projects. I don't know if you can resell them on eBay or whatever, but it's a thought. Okay. Now we're going to remove the bottom part, the bottom magnet, the through connector. This actually connects the signal cables to the back of the circuit board so that it can read and write to the media. And we'll just move watch that magnet, it's pretty powerful. And most of it just dumps out again. The screws as well as the magnet pulls out. There's a little arm here on this model, and that just slides off. This then becomes trash. And then out comes the servo motor. Now this is a perfectly good, high performance, very highly balanced 10,000 RPM motor. Terrific for projects if you're into that sort of thing. And then we peel out the through connector. The ribbon cable is connected here, and then the pins on the other side of that connector go to this connector, which connects to the bottom of the circuit board. This is e-waste. Again, this is going to be recycled. Okay, the last bit is this plastic, or maybe carbon fiber. I'm not really sure what the material is. This is actually put in with an aluminum rivet, this post. So we have to pry it out. There's no screw. It would be convenient for me if it was a screw, but I just used the brute force of a pair of channel locks. Now, I've done this a few times, so I know that if I pinch this, these shatter and little pieces fly all over my shop. So I'm going to cover it up with a cloth. Then I'll pinch it. There, you heard it crack into place. And muscle it out. And then what we have is the remainder pieces of the whatever that plastic is for. I'm not the engineer that designed it. I'm just taking it apart. That goes in the trash, and then what we have now is a clean piece of aluminum. This, with the plastic molded in as part of it, attached to it, that actually contaminates the aluminum, and they either have poor quality aluminum as a result, or they have to reject the part altogether and it ends up going in a landfill. So I like to take it apart and make sure that I've done my little little piece to save the planet. I'm not going to save the entire planet, but I certainly can save my part of it. Thank you for watching.